Okay, let's begin with homework exercise number 22 from section 6.1. The problem states in 2010, in 1,250 U.S. college students expecting to graduate in the next several years were surveyed. Respondents were asked the following question: what do you think your starting salary will be your first year after college? The line graph shows the percentage of college students who anticipated various salaries. The model P, using this formula here, describes the percentage of college students who anticipate a starting salary in thousands of dollars. Complete parts A through B below. Use the line graph, okay, so we're going to use the graph right here to estimate the percentage of students who anticipate a starting salary of $30,000. Okay, so the line graph here, the $30,000 is right there. Okay, and 30,000 looks like the dot is right around in here, right around in there, and it looks like it's about halfway between 20 and 24, so we're going to say about 22% according to the line graph. Okay, so that would be an estimate. From what we can see, we would say about 22%. Now use the formula to find a percentage of students. So now we're going to use this formula here. We're going to plug in P, where the starting salary is S in thousands. So what we're going to do is the starting salary is 30,000. So we're going to use this formula. P equals negative 0.01, and then S is the starting salary, 30 squared plus 0.8 times 30 plus 3.8, okay, and that will be our, and we'll substitute that, we'll put that into the formula using our calculator, and we see what we get. So again, using our calculator, we'll go ahead and put in the formula. It's a negative 0.01, and then it's the starting salary in thousands is 30 squared plus 0.8 times, again, starting salary, 30 for 30,000, plus 3.8, and we get an answer of 18.8%. Type in an integer or decimal, so it doesn't say round off, so we'll just put in exactly what it is, 18.8%, and it is correct. How does this compare to your estimate? The estimate in part A was 18.8. So then actually, how does it compare to your estimate in part A? How does this compare? So this compares to part A is actually a little bit less than the estimate, okay? Because the estimate is from part A, all right? Very good. All right, let's look at number 23. The amount of alcohol in a person's blood is known as the blood alcohol concentration, BAC, measured in grams per deciliter of blood. A BAC of 0.08, meaning 0.08%, indicates that a person has 8 parts alcohol per 1,000 parts blood. It is illegal to drive with a BAC of 0.08. Using the formula where W is the weight of a 168-pound person and N is the number of drinks per hour, and a calculator to compute the BAC for integers 1 through 10, how many drinks can a person consume in an hour without exceeding the legal measure of drunk driving? Again, what we're going to do is we're going to look for 0.08, right? So what we're going to do is we're going to put into this formula 600, and then we're going to put times N. We'll start with 1, and the weight is going to be for a 168-pound person. So we'll use this formula right here, okay? Now again, what we can do is you got to make sure, okay, so we're going to go ahead and use this formula. We're going to first try N is 1. So we've got in the numerator, we'll put a big parentheses around the entire numerator. That's to do the order of operations. So you do 600 times 1 and then it's a division, and then you're going to put a parentheses around the whole denominator. So it's going to be W, the person's weight, is 168 times 0.6 times 1 plus 169 is a constant. And then we have a parentheses around that. Then we need another right paren around the whole denominator. And we're going to hit enter. And we get 0.02. So we're below the limit. Okay, so now we're going to go ahead and try n is equal to 2. Same formula. The weight is 168, and we'll put n as 2. So now we're going to put 600. Actually, we'll put in the right paren 600 times 2 divided by the entire denominator, the person's weight 168 times 0.6 times 2 plus 169, and then 2 right parens for the one grouping of 0.06 and for the other grouping of the whole denominator, and we get 0.04. So we're still below. So now we're going to go ahead and do n is equal to 3. We'll just keep on going until we get above 0.08. Then we know we stop. So now we have 600 times 3 divided by right paren 168 times left paren 0.6 times 3 plus 169, 2 right parens, and we get 0.0627, so we're still below it. So let's do n is equal to 4. 600 times 4, I forgot to do parentheses around the entire numerator, 600 times 4 divided by left paren, person's weight, 168 times 0.6 times 4 plus 169, 2 right parens, and we get 0.08, which is above. So for 4 drinks, we would be above. So that means, according to this model, a person can consume 3 drinks without exceeding the legal measure of drunk driving. So it would be 3 drinks. All right, very good. So again, we use the formula given right here, and we just kept on putting n equals 1, 2, 3, 4. At 4 over here, we got 0.08. We got too high, so then it's 3 drinks per minute. And again, that's the n in the formula, and the W is the weight, which we were putting in 168 pounds. All right? Very good. A business, number 24, a business that manufactures small alarm clocks has weekly fixed incomes of weekly fixed costs of $4,000. The average cost per clock for the business to manufacture X clocks is described by 0.4x plus 4,000 divided by X. Find the average cost when X is 100, 1,000, and 10,000. So again, we're going to put in the formula. Okay, for 100, we're going to put in X is 100, right? So we have the numerator in a parentheses to group it together, 0.4 times 100, because we're putting in 100, plus 4,000, okay, and then we're dividing by X, which is 100, and we get $40.40. Okay, now we're going to do the same thing when X is 1,000. So same formula, but now X is 1,000. So 0.4 times 1,000, because X is now 1,000, plus 4,000 divided by X again, in this case is 1,000. And we get 4.4, $4.40. Now we're going to put in 10,000. So again, 0.4 times 10,000 plus 4,000 divided by 10,000 and we get 0.8, which would represent 80 cents. Now, does this business have much of a future? Our manufacturer can produce 2,000 clocks weekly. Let's go ahead. Like all other businesses, let's read B. Like all other businesses, the alarm clock manufacturer must make a profit. To do this, each clock must be sold for at least 50 cents more than what it costs to manufacture. Due to the competition from a larger company, the clocks can be sold for $1.50 each and no more. Our small manufacturer can only produce 2,000 clocks weekly. Does this business model have much of a chance of a future? Well, what we're going to do is we're going to use our formula again, and we're going to substitute in 2,000, and we're going to see how much the average cost per clock is, and then what do we got to do? They can only sell it for $1.50, so we got to compare that to $1.50. So what we'll do now is we'll put in 2,000 into the formula and determine how much it costs per clock. So now we're going to put in 2,000. So we're going to go ahead and use the same formula, which is 0.4 times 2,000 plus 4,000 divided by X, which is 2,000. That's how many they can produce weekly, and they get $2.40. So this is going to be how much it costs. So the cost is $2.40. They can only sell it for $1.50. So obviously the cost we just did from the formula is $2.40. The sold, what they're going to get is $1.50, where it's costing them more to produce than what they can sell, so obviously they're not going to make any money. So does this have no, the average cost per producing 2,000 alarm clocks is much greater than the selling price. So there's our answer. They don't have a future because obviously they would be losing money on each clock they produce. All right, very good. This concludes this session. If you have any questions, call me at 239-938-7805. This ends all the problems from this section, section 6.1. Thank you.